In this video lecture, I will explain how to construct a push-down automata for A par n, B par m, C par n. And here DPDA means deterministic push-down automata. So the language is A par n, B par m, C par n for n and m greater than and equal to 1. So you can see here A par n, B par m, C par n means the number of A and C are same and B can be anything. So any number of B but same number of A and same number of C. Okay, so my string will be something like this. If I have one A, I will have any number of B on same number of C. So A and C should be same. Same way, if I have, suppose if I say I have 3 A's, B can be any number of anything, I mean any number of B, and then 3 C. So we have to match A and C. This B can be anything. So what is the approach we are going to apply here? For A, when we read A, we will push it onto the stack, and then after A, B will come. Okay, so when B comes, we will not do anything. So for A, we are going to perform push operation. For B, do nothing. Okay, and for C, we are going to pop. Okay, so in stack, we will have, okay, initially we will have Z0. Okay, or we can say Z also, and then when we read the first A, Z0 is there in the on the top of the stack, so we are going to push A into the stack. Then we read second A is only on the top, we are going to push. We read third A is only there on the top, we are going to push that also. And then when we read B, after A, B comes. Any number of B comes, we are not going to perform any operation. We read B, top of the stack will be A only, because before B, A will be there. Okay, so top of the stack is A, we are not performing anything, let it be like this only. Second B, we read top of the stack is A, don't do anything. Third B, we read top of the stack is A, don't do anything. So like that, any number of B we read, any B we read, top of the stack is A, don't perform any operation. And then once B's are over, C comes. So as soon as C comes, the top of the stack will be A only, because we have not done anything. When we read B, we did not perform any push or pop operation, so the content of the stack did not change. So when we read C, first C, the top of the stack is A, we are going to pop it. We read second A, second C, top of the stack is A, we are going to pop this second A. We are reading third C, the top of the stack is this, we are going to pop it. And then epsilon means end of the input. When we read epsilon, what is there on the top? Z is there on the top, and we will go to the final state. So this is the transition graph. So we are in start state Q0. Okay, we read A, first A, so top of the stack is Z0. Z means we are going to push it. When we read second A, top of the stack is A. AA means we are going to push it onto the stack. So this will take care of any number of A. And both the transition in transition form, how we will write? We are in state Q0, read first A, Z is there on the top, push it onto the stack. We read second A, top of the stack is A, we will remain in the same state and we will push that A onto the stack. So this AA represent the top of the stack is A and bottom also is, I mean the next symbol is A only. And then when we read B, we are in state Q0. As soon as B comes, the top of the stack will be A only, and we are going to change the state from Q0 to Q1, and top of the stack, I mean we are not performing any operation, so whatever is there on the top, it will remain same. So here we read B, A is on the top, A only will be there on the stack, we are not performing any operation. Otherwise push and pop, how we will do? Whatever, see here we were reading A was there on the top, so AA means we are going to insert. If I have to pop means, if I say okay, we are reading B, A is there on the top, pop means we will write epsilon here. So here whatever is there in the top, that only is there in the top, means we are not going to perform anything, any operation. And then this self loop on Q1 will take care of any number of B I get, top of the stack will be A only, and the top of the stack will not change, means we are not performing any operation. And then as soon as C comes, the first C comes, top of the stack will be definitely A only, and epsilon means C comma A slash epsilon means we are going to perform pop operation, and then we are going to change the state, and then this self loop on C will take care of any number of C we read, top of the stack will be A only, because for each A there will be C, because A and C should be same. So we are going to perform pop operation. So we keep pushing we will pop, sorry, we will not push, we will pop the corresponding A from the stack, and then once epsilon is encountered, that means end of the input, top of the stack will be, after popping all the A from the stack content will be Z only, and when we read epsilon, Z is there on the top, so this epsilon represent end of the input. So when epsilon comes, that means end of the input, Z is there on the top, we will go to the final state QF and we will not do anything. So this is how we will write the transition function, and this is transition graph representation of push down automata, and this is deterministic push down automata. So hope you have understood the concept. Thank you for watching.